I'm going to have to take things a little easy today, so, this might be a bit more of a chill, laid-back class. We're all in the chill zone. We are super cash. Right? I am in my super casual sweater. So we're in super cash mode. I'm wearing my casual shoes. Very good. So, any questions about anything before we get started? You guys get a start on assignment 1? That's going well? Good. HTML and CSS is not the hard languages that we're going to do, right? That's okay. So, speaking of hard languages, dun 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 dun. JavaScript. So, hello, welcome. Come. It's okay, we just got started. So, JavaScript then. So JavaScript is notable for being the only programming language which you can use on a client. It embeds into web pages, and there is no other language which does this. We are forced to use JavaScript when we are writing code for web pages. It's not a choice. We don't use JavaScript by choice. We use it by obligation. Nobody would really use it if they had the choice, because it's a horrible, horrible language, as we are going to explore. So, technically, JavaScript is an implementation by browsers of the ECMAScript language. This is why you'll see newer iterations of JavaScript discussed as ES6 or ECMAScript version 6. The first iterations appeared in Netscape Navigator 2.0 in the year 1995. It's not really related to Java. It was named JavaScript for marketing reasons. You guys know polka dots? Have I done this example yet? No? You know polka dots? Like the pattern, the fabric pattern polka dots? Here. The polka dot fabric pattern, right? Why do you think it's called polka dots?
Bunch of dots.
Eh, what?
It's a bunch of dots.
It's a bunch of dots. I mean, it's hard to say.
It's fun to say.
It's fun to say. Polka, yep. So, way back in the olden times, they didn't have television or the internet. So what you had was dance crazes. And waltz at one point was a dance craze. Another thing that was a dance craze at one point was the polka. And the polka was just extremely popular. And it was so popular that one fabric manufacturer, I don't know who, decided to take their new exciting fabric patterns that they had recently come up with, and they named it polka dots because you should wear polka dots to your polka dance, which is the new and current thing. What do polka dots have to do with the polka dance? Nothing. This is the same relationship that JavaScript has to Java. So do not worry that you do not know Java. It is fine. You know, well, you don't know Java, but you know some C#. C# is Microsoft's Java, so in a way you know some Java. But don't worry that you don't, like, think of this as being a different language, because it functions very, very differently. So, what is the purpose of JavaScript? Number one, well, the purpose of all programming languages is to receive input and produce output. Right? This is not only the purpose of all programming languages, but the purpose of all programs. In the case of Java, what we take as input are typically events and data which has been selected or entered in by the user. The output is, sometimes it's changes to the web page, sometimes it is sending data back to the server, sometimes it's fetching more data from the server. It does a lot of different things. It's situational. No matter what it's doing, there is something that appears for the end user most of the time. Otherwise, what's the point? JavaScript can handle events like clicks, hovers, changes to data, the sorts of things that we had started getting into with Windows forms at the end of last semester, right? We made a button, we created a quick event for that button, we hooked up some code to it, we had, event-driven behavior. Event-driven behavior is largely how JavaScript likes to operate. So we are back in that territory with JavaScript. JavaScript can make requests for data to the server. Now, this is a little bit different from our concept of the sort of web classic design of client and server. If we recall how client and server typically we think about them, right? All requests, when we create a request packet, what is it specifically that we're requesting? What is the subject of the request? Sort of in classical web architecture.
An order?
Oh, what, sorry?
Is it like an order?
An older?
Order.
Order? No, not an order. Yes?
A web page?
A web page, or more generally, a file, right? So in general, what the internet is kind of designed for is it's designed to be a big distributed file system, right? This server has these files available, and it serves requests for those files. That's kind of web classic, right? That's how things were for a reasonably long period of time. Along comes a method of communication called AJAX. Now, AJAX requests are using the exact same infrastructure as regular web requests and will also be for remote resources. The trick is they are not expecting a file back. They are normally requesting some data. Now, you might say to yourself, well, surely we could put the data in a file and then it would be a file. But the data that we are requesting is not necessarily coming from a file. It could be taken from a database. It could be generated by the server on the spot. it does not necessarily have to be a request for an existing file in memory. That's an AJAX request. Most of the time, AJAX requests will get information back in the form of JSON data, JavaScript object notation. We don't have to worry about that right now. That's a topic we're going to get into later on. Okay? Any questions so far? So, basically, what the AJAX request allows us to do is to load more information from the server into the web page without reloading it. Right? So think about your social media feed. When you're scrolling through your feed, right? How many posts can you view before you have to hit next page? Exactly. You don't have to reload the page to get your next set of posts. Why? The next posts are being loaded into the page using JavaScript and using AJAX requests. The website is going to the server and saying, hey, I need the next 30 posts, please. The server is like, yeah, here you go. And then it seamlessly integrates that into the web page for you without you having to, do anything about it. Make sense? Any questions? Okay. Yeah.
Where does the speed come in this? I mean, when you scroll down to the page, if you scroll down very fast, you might see some loading and it gets very slow.
Yes. That's because you can only transfer the data into your phone so fast, right? If you're just like, whoosh, 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 basically you're like skimming through posts faster than the website can request and supply them. So you will eventually hit that like loading, and then once it's loaded, it'll fill in the rest, and then
So they have made a study like about the average of how much a person would last on specific posts.
Oh yeah, that like, I mean, if you want to get into it, like the sorry, I gotta take my sweater off. There's a lot of research, nasty marketing, nasty manipulative psychological research that's going into exactly how much, like what the precise delays should be to do this, that, and the other on social media. Like for example, basically a social media feed, the closest thing to it is a slot machine, right? Because basically what the machine is dispensing is the dopamine hit that you get when you see a post. It's like how people get they used to talk about this back when people took phone calls, but like there's a certain type of person that gets a dopamine hit when they get a phone call, it's like that, It's like, oh, I'm seeing the meme, I get the dopamine, right? So it turns out that like what you do is you introduce a little bit of a lag, just enough to get them like primed and really wanting it, and then you hit them with it. That makes it much more effective, right? But that delay is like very small. I think it's a fraction of a second or something, just long enough for your brain to like not get what it wants immediately, right? But yeah, social media is basically evil, and you shouldn't use it because it's bad for your brain. And children in particular shouldn't be allowed to use it. Because, like, you know, if they can't use slot machines, why can they use social media? So, you know, because on social media, like on a slot machine, you're only gambling with money, right? On social media, the coins that you're putting into the slot are your time, which is far more precious. So, anyway, JavaScript is interpreted by the browser. So, I probably had this discussion with you last semester, but let's see how much you guys remember. Do you guys know the difference between a compiled and an interpreted language? Did we have this discussion? Did? Yeah.
See the difference in like the way that it interprets, the way that it kind of like reads the data, like the order that it like executes it perhaps?
Not necessarily order, but thoroughness. So basically, with a compiled language, the program is read in all at once. The entire program is loaded into the compiler. It chunks through all of the data, does lots of processing, and produces an executable as a result. With interpreted languages, you are feeding a script in one line at a time, and the interpreter is processing that script one line at a time. So there are advantages and disadvantages. In general, you know, despite a claim being made here, it is still generally true that interpreted languages are much slower than compiled languages, as compiled languages are running directly on the operating system. But one of the advantages of interpreted scripts is that an interpreter can be stuck inside of another larger program. This is what happens in the browser. The JavaScript interpreter is stuck inside of the browser, and it reads JavaScript one line at a time from the browser. I think that's there we go. Good. So, So the browser receives its JavaScript as an uncompiled plain text, the same way that it does HTML and CSS. So when we write a JavaScript file, it is fetched and decoded in much the same way that CSS is fetched and decoded. The browser then interprets, compiles, and executes each line of JavaScript as it encounters them. All good? So, modern engines are much faster, allowing for better front-end JS and even back-end JS. For example, Node.js, which is a back-end server language. Basically, improvements in things over time have meant that these compiled languages have improved. Things you wouldn't have used them for 20 years ago, we're now using them for. JavaScript in particular is an interesting one, as it's far and away the most programmed in programming language. I would like to call you to the 2024 Stack Overflow Developer Survey, which is has fascinating data. This is a survey of who uses what, who actually uses what. So, for example, 63.2% of all developers have used JavaScript in the last year. But where's the data though? Give me the data. Here we go. Maybe not. There we go. So, this may be of some interest to you. This is a list of what programming languages were used last year. You can see that JavaScript is right at the top, comfortable lead. Next we have HTML, CSS, so you can see how much of total work is in web these days, right? Next you have Python. Next you have structured query language, which is another one we're going to be talking about in this course. This is, TS is TypeScript. TypeScript is a, it's trying to be a better version of JavaScript. So, we'll see how that pans out, but it's been gaining ground every year for some years now. Bash Shell, where I personally do most of my work these days. Java, C#, C++, C, PHP, PowerShell, Go, Rust, Kotlin, Lua, Dart, and then of course you've got all the small ones to fill out the list. To fill out the list. Yes.
What's the difference between Java and JavaScript?
I was about to ask that.
Java looks, feels, and plays basically almost exactly similar to C# from last semester, minus all of the Unity crap, and minus all of the Windows Forms crap. If you kind of take all of that crap out, and what's left behind is Java, right? I don't know, I almost want to say, stay tuned for what JavaScript feels like, because I'm kind of in the middle of slides explaining the difference. But okay, I'll go over a couple of them right now. Number one, JavaScript does not have the same approach to typing. You don't need to know the type of the thing when you're declaring the variable. It'll make a best guess. This can lead to many problems, right? Because it's a less precise language. It has two equality comparisons, weak and strong equality. Weak equality violates basic laws of logic. And I'm not even being facetious. So here's a basic law of logic for you, all right? If A implies B, with me so far? If A implies B, right? And B implies C, right? With me? Therefore, we can conclude initialize C. Right?
Yeah.
We can also replace these with equal signs. If A equals B and B equals C, A should be equal to C. Am I right? Ready for some? You want to see some stuff? Because any web page you can just pull open the console and start messing around with JavaScript, right? So watch this, my fine fellows. 0 is equal to 0. Okay?
That's true.
I mean, not in Java, not in C#, right? Why wouldn't this be true in C#?
So one's a value and one's a string.
Yeah, one's an integer and one's a string, right? So these are different data types. So this is what JavaScript is doing, is it's already it's confusing its data types. 0 is also equal to this thing, the empty string. Is this equal to that? Nope. So yeah, JavaScript violates basic laws of logic, at least under weak equality. So what's its solution to this? It has triple equals. Triple equals evaluates both value and type. So it says, I believe what is going on in the back end in JavaScript is that all data is being kept in the same format and it's being tagged with its data type somehow, and then basically this one is just evaluate the value, this is evaluate type tags. So I sometimes make the joke with students that in JavaScript there's only one type and that type is garbage. So a strong, strict, statically typed language like JavaScript, or like C# or Java, would never let this kind of nonsense fly. There's also a whole bunch of things you can, there's this very interesting set of things you can do with Java. It's actually, or JavaScript, it's actually possible to program all JavaScript programs using only 6 characters. Watch this. So, the 6 characters are this. You've got Boolean negation, round braces, square braces, and the addition operator, all right? So that's an empty list. So empty list is empty list. What is not empty list? Not empty list is false. What is not empty list? Not empty list is true, because not false is true. What is, oh yeah, you want that as a string? I can get you that as a string. There's some way of doing it. Let me think here. Let me see if I can remember it. No, I think, I think it's, if you take true and then you add, yeah. So true added to nothing gets you 1. 2, 3, etc. So that's how you get all of your numbers. You shouldn't be able to do this. There's no language where this, So what this is called is esoteric programming. There are actual esoteric programming languages which have been developed, most of the time as jokes. So this is probably the most famous example of an esoteric programming language, which actually, these operations map to actual Turing machine operations, but it's famous for having the smallest compiler. The size of the compiler for this language is under a kilobyte. Yeah, that's basically, people make these types of languages for jokes and for fun, but JavaScript contains one accidentally. So it's a terrible language. But anyway,
What makes it so much used if it's so terrible? Like, why do you use C# more?
people didn't think the internet would be as big as it got. Like actually though, like over time everything's been moving more and more towards a web framework, right? Like, think about it this way. How many of you have jobs? Like you do some kind of work, right?
It's good order.
Yeah. How much do you work on a computer?
Yeah, I do some people work sometimes.
How much of that computer work that you do is actually in a browser?
Not too much. It's kind of an app. Like,
It's an app.
yeah, but like I can open it in a browser or I can just download the app.
If you can open it in a browser or you can open it in an app, what that means is that the app is actually a stripped down web browser. So, in fact, you have been doing your work inside of a web browser this entire time. So an interesting place you can see this happening is like even within the context of people's jobs. You know, back in the 90s, if you were working on a computer professionally, most of the time you were doing things like word processing and spreadsheets and database stuff, but you were using like native applications. You were using installed applications, right? These days, most of that is gone, right? Much of the time when people are using even things like Word and spreadsheets and things like that, they're like a lot of the time they're even doing it inside of browsers, right? Like over time, everything has been happening inside of a browser or in something that thinks it's a browser or a stripped down version, that an app for the website, which is just a browser, right? It's a browser without a nav bar. And it's just kind of the way things have been going, like I don't think anybody planned it this way. It's just, it just happens to be the easiest way to connect you to a server, and over time we've just required more and more connection to servers, so. And JavaScript's the front end and the server's the back end, and that's just kind of how it goes. But it also, like, believe it or not, the JavaScript of today is much, much better than it was, 10 years ago even. So, yeah, people are even using JavaScript for stuff they don't have to use it for anymore. But, so it goes. So, JavaScript is a multi-paradigm language. So it is imperative. You can use statements. and variables like in C. It is an object-oriented language, so it has objects and classes, although the way that it has objects and classes are highly different from how they worked in C#. Don't worry, you basically don't have to remember any of it from C#, which is probably good, as bloody inheritance, am I right? Functional. So, functional is an interesting language paradigm. I personally am highly well acquainted with functional programming. I did quite a lot of it in my university days. So functions, right? Take a function and pass it to a function as an argument. Then expect from that function another function as the return result, and you've kind of got your head into the sort of space where you're thinking functionally. Functions are thought of as first-class members of the language. We can define a function and pass it around like it's a variable. All right? JavaScript is dynamically typed. Variables can hold values of any type if you don't need to specify the type of your variables. So for example, the way that you declare a variable x having a value 5 is var x is equal to 5. There are actually a couple of ways to do this, but this is good for now. So you'll notice that the word var does not imply a data type, right? We don't need to know the data type going in. It figures it out as we go. JavaScript is weakly typed. So where C# would have complained and prevented your program from compiling if you tried to perform 5 plus the string 5, in JavaScript that works. But let me ask you a question. Using all of your powers of observation and deduction, what do you think the result would be? I'm going to put two expressions on the board. Five plus the string 5 and the string 5 plus 5. The answers should be 10 or the string 10. For the first one, who thinks the answer will be the integer 10? How many people think the string 10? For the second one, how many people think it will be the integer 10? How many people think it will be the string 10? But kind of the whole point of this exercise is that it's perhaps not obvious which one will be the result, right? Did you just try it?
Both the string.
Both string. There you go. Gross, am I right? Now, a JavaScript advocate would probably say something like, oh, well, it doesn't really matter that it's a string anyways because it's weakly, it weakly evaluates and can be added to anything. Why do you need to know it's a string, man?
We got
Yeah? Sorry?
10. I got 55 in the string.
You got 50? Okay. Let's see
That's
here.
what I was expecting. I was expecting it to just like 5 plus 5 as a string, not actually doing the addition.
Ah. Well,
Like you're adding 2 characters together instead.
There's some way of coercing it to do this. What, does this mean the slides are wrong? What is going on? Oh my goodness.
I mean, still valid, it's not an error.
Does casting work? Yeah. No. Everybody is wrong. I hate it. I hate JavaScript. All right. I apologize for misleading you. It was not intentional. Again, this is why I hate JavaScript. So the addition sign is coercing this guy to be a string, which means that this is now a concatenation operation. So 1 plus 1 is 11, rather than 2. I know, right?
Did that mean it's like kindergarten?
Yeah. Good grief. So basically, this is the thing I'm going to ask all of you to do. Try to ignore the fact you're using JavaScript. Program it like it's C#. The syntax will mostly match up. You'll have to make some modifications. But if you hold all of your types in your brain from last semester, JavaScript isn't going to help you. But if you just program it like it's C#, you'll run into fewer problems. If you try to rely on stuff like that, you know, it becomes difficult to predict, right? So if you just say, okay, no, this variable is a string, I don't want it to be anything else other than a string. This is an integer, I want it to do integer things. Then, you know, basically this is the problem. This is like the real problem with JavaScript is because it's not doing that work for you, you have to do it yourself. And it thinks it's being helpful, but it's not. Anyway. So, there are basically, you may recall with CSS there were 3 ways to include CSS in our HTML file, right? We had inline, which you should avoid, in a style block, which is better than inline but should still be avoided, and then in an external file, which is the preferred way of doing it, right? In JavaScript, we basically have 2 ways of doing it. Inside of a script block, which should be avoided, and externally in a JavaScript script. These are the 2 syntaxes for that. So if you, and get my lightsaber. There we go. If you take a look at the script tag, the source attribute targets the name of the JavaScript file. So you can see now how it is that JavaScript integrates into the web page. There is an actual HTML element type for it, right? You can just open one up, put a bunch of JavaScript and then close it. But again, this means that that JavaScript is stuck in that file and can't be used on any other pages, right? Occasionally, we will make references to the JavaScript inline, but this is not the same thing as inline CSS. Please direct your attention here. We have a button element with an onClick attribute hooking it up to a JavaScript function. This is not the declaration of the function, this is a use of the function, right? So we can take our JavaScript functions as defined in our file, and we can hook them up to other page elements by making references to things. I think that's actually a good point to try that out. So if you could please, everybody, open up whatever your code editor of choice is. We haven't yet gotten to the point where we can do much that's interesting, but we can do a little bit of stuff. So, just make yourself a handy, tidy little HTML page. Doesn't have to do much. So, normally, our JavaScript inclusions are put into the head of the document. And I'll show you a neat little thing with VS Code. If you just boldly assert that I have a source code file named myscript.js, it will underline it for you. And if you hold Control and click it, that's the shortcut for going to the file.
Can you please go back?
Yes. If you hold Control and click, that follows the link. But of course it follows the link to a file that doesn't exist. But it gives you a little dialog to create it. That way you never mess up your file names. Question?
Can you do the same thing for CSS source code?
Absolutely. Pretty sure you can do that for pretty much anything, actually. Anything it'll link to, anyway. Which is most things. So, shall we do Hello World? I think we already, didn't we already do Hello World? Wow,
It's always hello world.
yeah. In JavaScript, I'll do two different Hello Worlds with you, and we'll see a third one a bit later. The first one is console.log. There we go. Now, if you load the web page, you're like, where's my hello world? Inspect, console, there she is. Hello world.
On my Mac, it was control cover, and then let go control.
So this is the console. When you hit console, or when you invoke console.log, that is where your message appears. The console, its full title, is the developer console. This is printing information in a place where the end user, in theory, should never see it. Right? I am willing to bet that 99.973% of normies have no idea that this thing even exists. Right? And they wouldn't know what they were looking at even if they accidentally opened it. So, this is information for developers. This is not how you present information to the user. Let me now show you Hello World style number 2, which is the alert box. Alert, hello world. Note, when we reload the page, we get this box at the top saying the message. We must click OK in order to continue rendering the page. Notice that nothing appears, right? The alert box pauses everything until the user clicks OK. In general, this is terrible, terrible user design. I don't use alert boxes. They're not the way to get done what you want to get done. Okay? There's plenty of stuff you can do inside of this, inside of the actual web page, that you don't need to use this as part of your user interface design. It's terrible. Don't do it. Okay? But it's kind of interesting for poking around the corners of like when the browser actually renders things, because this does actually pause browser rendering. As you will see, if I click OK, my web page pops in. So that's the other way to be able to print stuff. And of course, there's also, alert. Slacking off on the job. Hey, Jenkins. You can close this, and then you know. Again, normies often don't know that this is possible or that you can set those, so they think it's either the web page or the internet itself talking to them, you know. So if you're interested in like the applications of websites as Ouija boards, there you go. Fool your friends, confound your enemies. Good. So, I think I'm going to structure things a little bit differently this time. I'm going to declare a 10-minute break here, and then we will resume class in 10 minutes. Okay? Yeah. I also need to go to the one.
I guess it was like a super easy.
Oh, there does look like go back. Go back. Go back to the web page. It says you have an error here. Right click.
That's good. Like, it's nice to be smart. You guys did the work, you did what you're supposed to do. Go grab a coffee.
Your JavaScript again? No, that's your HTML. You're not getting this one. Go back to the scripts. Yes. That'll do it. That will do it 100% of the time.
Question.
Yeah.
Do you like Python or you good? I assume you know everything. If I send you a code, can you debug it for me? If I send you what the error it sent me as well?
Only if you call it a program and not a code.
If I send you the program,
Yes, yeah, I taught Python for years. However, I also, at one time I had a very good reputation for like really hating that language too. But that doesn't mean I don't know it.
it's just in our operating class, he wanted us to do our assignment in it. And I think it's my array. That's the problem. I already had the email written up. I just wanted to ask you before I sent it.
Absolutely.
You're done for. You're done for. You're so done for. There's no way you're done for. This guy's done for, bro. This guy's done for. Seems actually awesome. You're done for, man. Why is that? Why did you love me?
The code that Bash has to write is super easy, but like, it's, once you start writing the language, it's different.
Yeah, it's not.
It's like the same concept, but you feel every time you want to write something, like, so how you would do it. It's not just like Bash, because you want us to do it in Python.
But we can do it. Command prompt.
Huh?
We're supposed to do it in command prompt. Using the.
In his email, he said to download Python.
But like in class, he said you can use this one.
You can do Python in that though.
Yeah. So are you gonna do it in this one?
Yeah, I'm doing VS Code. It's insane to do it in VS Code, to do it in that.
Like have you done it or are you gonna do it tonight?
I've done A, but I'm getting an error, so I'm gonna get Nick to look at it.
It's not doing this tomorrow. So.
Yeah, so I started it, and then B is much easier than A. A looks like it's the hardest one. And it bites threads, I'm assuming you use functions, right?
Yeah.
It's good because it's how we.
Good practice.
And so when I read the question, I was like, it has to be functions.
First lab, we had it so easy, but like for this one, it actually missed the class because he's like so he didn't get his chance to explain.
Yeah, I don't think he's ever planning on actually taking us to language. He literally wants us to learn it. But he didn't address the fact that like does he want us to teach do it in Bash? Does he told us Python and that's
I think he's gonna be back tomorrow because like not like we're gonna be on.
Travis and they said that it was just science. Did like the last class.
He told us the class before we were behind, so we have to memory. On Wednesday we gotta come back, so that's try
We're behind.
We had something.
Keep it running, not
He's
running.
studying. The other day he asked me in his class, he was like, is the front supposed to be here? I'm like, yes. And he was like, how's the class? I'm like, fine, it just looks like it's a lot of material. He was like,
He seems like he's surprised by how much material
Yeah.
they're expecting when we look for it.
but yeah.
Yeah, I know,
How do
right?
you start with the
So you submit it?
It's pretty easy.
And yeah, I'm not worried about that one. I don't think so. When's the due?
You said you wanted to add stuff.
On Sunday, we said.
That's half
But
the
on
year.
Friday we have two assignments to do, so we should divide the work for the information management one.
Yeah, he's like, wait.
Yeah, we have the
I already
assignment
sent
for,
them like a comment on that.
what other assignment?
I already submitted. Why did you give
Math,
us zero?
was the assignment.
How did you do this? It was.
I think I got
wanted
8.
to make an addition so that you would.
I got one question like where, but now that I like afterwards, I realized what the answer was.
Oh, that's fine.
But yeah. And yeah.
It wasn't that bad, it was only one question left.
That's part of the.
Yeah.
Which one was that? Mine was the one.
6, it was for equalities or something.
Sounds. I pulled it out.
Oh, you did it on paper?
Yeah, I like worked worked on paper before I submitted any of my answers.
Oh,
That way I can like, because I work on it kind of like here and there. Question 9, that messed me up.
Yeah, this seems possible.
It was like,
Oh, stop cheating. Stop cheating.
one of the, what's it called?
I did that. I did. That's what I'm saying. I did that.
Florida.
other than that,
What is it?
I did that.
it's good.
Why am I not work?
It's just other than something that's stressing me out.
What's on
It's
one?
gonna be a surprise.
We're pretty slow
It makes
today.
it seem like it's gonna be easy, but when I do it,
Yeah, how are you planning on doing, you like assignments for the
It's
teachers?
not working, Chris.
We
Yo,
were, I
explain
got
this
with
to
Chris
me.
and Travis and we were like, there's a makeup
No, we're going to.
say I didn't.
but she also wants us to do like a diagram or something that would be,
Oh my God.
But it's just based on
How did you
like,
get this?
or the map she said.
What do you mean you did?
but like, she wants us to like talk about it, like have like the interview and then
Yeah.
everything goes Wednesday and then I think she's gonna explain how she wants to sign.
There's no link.
Hopefully. It was super, when I was like, hey, how do you actually want like this homework to be formatted? She didn't really give me a clear answer.
Makes sense, but
I don't like that
they
part.
just made it like this, click on it and made a second
It's
one.
not,
Shut
it's
down.
just
What the
not, it's not all that.
Yeah, that's what I'm saying.
It's super easy,
Yeah, it's not
yeah.
all that, she's just like, with expectations higher.
Yeah. It's like, what do you do like about that class? It's like there's not much to do outside of class, like literally
Yeah, the
everything you
lab.
learn during lab.
Yeah. And the lecture, I find it so boring.
I thought it's like,
Exactly.
super much.
Oh, I like that.
She's wearing a Star Wars outfit, and I figured
Yeah.
people ask often if she's a boy or a girl, because at this age, everybody looks like a boy.
Yeah.
So
But
it's a bow.
it's weird that she, like, she actually has a lot of.
She does not get it.
Was she born with like that, or?
Yeah, she was born with a lot of hair. Like, I was literally, I got it, she gets it from my boyfriend. My son, who is my twin, who was born bald, and like, me and all my brothers, who all look very similar, are all bald. Yeah. I got really bad heartburn with her, but I also got really bad heartburn with my son. They say if you get heartburn during pregnancy, the baby's gonna have a lot of hair. And I was literally, well, like on the operating table, because I was C-section, talking to my doctor about how I'm getting heartburn. And I was like, it's, you know, it's BS because I know she's gonna be bald. Like, I know she's gonna be bald. And then he picked her up, because he like took her out of me. He's like, well, she's definitely not bald. And he like lowered the little thing, because they like don't want you to see yourself kind of like, you know, it's like,
Go far.
no, I did a C-section, like I had a cesarean.
Both of your.
Yeah, so with my son, I wanted a C-section and I talked myself out of it.
It was your first that was carrying.
Yeah, and I talked myself out of it.
Okay, what did I do
And then I ended
wrong?
up having to have an emergency C-section anyway, because it was free.
Oh.
And I
I
just,
heard like for C-section, it takes longer to recover.
No, I wrote that.
like, yes and
So
no.
you don't feel the big journey, you feel it after.
Yes and no, like, I got lucky, my recoveries were fantastic, within 2 days, like, I barely felt anything. But like, not everybody's like that, like, I know people who got C-sections who had long recoveries, that kind of, it also depends on like, your physical fitness before the surgery a lot. But I love having a C-section, both times, very, you just have to take it slowly.
What?
If you rush your recovery, like, I couldn't pick up my son for like 4 weeks after having her, because like, you can pop and shift you. If you're lifting heavy things, you're not supposed to lift anything heavier than your baby.
Yeah.
But no, I love it. So with him, he was breached. I had which I was okay with anyways, because I kind of already wanted a C-section. And then with her, like, I enjoyed my C-section so much the first time. I was like, I want to do C-section, no problem. And then I found out the day of the C-section, even if I chose to have her naturally, I would have had to have an emergency C-section anyway, so she was sideways. She was her head was in my ribs and her feet were my other ribs. And she was sideways, not like straight front, and she had a knot in her umbilical cord, which was fine how it was because it wasn't a tight knot, so everything could still flow through. But if I did it naturally, it would have pulled it tight, and then there would have been complications. So yeah, it was nice that like I already wanted the C-section, and then it was confirmed that I made the right decision. Yeah. So apparently I don't make babies that are facing the right way.
I love those. I always think they're so great.
My grandpa used to buy these all the time, and I love them.
So good.
Okay. Shall we resume then? Lovely. So, here, let me kill the lights a little. So, at this point, I think it might be valuable to do a little bit of a rundown, a little bit of a review of all of the stuff that you guys, or, selected key topics from last semester. See how those code constructs look in JavaScript. Sound good?
Yes.
Good. So, let's start with variables. So, we didn't get a huge degree into scoping rules in variables last semester, but basically there are two ways that you can declare a variable in JavaScript. With the var keyword or with the let keyword. Let is the local binding, var is the global binding. Okay? So when you use var, that means I want this to be a variable everywhere. Let, only within the context it exists. So if you use let, yes, question?
Oh yeah, so is var just like public and let is like private?
It's a little bit like private and public. We don't really have a concept of privacy in JavaScript. Some of you might be like, yay! So it's more like, where is this thing accessible? So basically, if you have a function, right? If you bind something locally to that function, it exists inside that function, but nowhere else. Does that make sense? So that's what let is for. Aside from that, aside from all of the stuff I was alluding to earlier, where the types of things are somewhat mysterious, variables otherwise function exactly the way that they did in C# and exactly the way they do pretty much everywhere else. If you want to assign to a variable, you put it on the left-hand side of the equal sign. if you want to use that value for a computation, you put that variable on the right-hand side. So what is the computed result of x after this statement? 15. Very good. So in that respect, things are working in JavaScript quite as we expected. As long as you don't mix your types, right? That's the trick with JavaScript. As long as you don't mix your types, things work the way you expect them to. Good. So, if statements. If statements. If y is less than 50, console.log yes, else console.log no. Now, I am not getting any red underlined syntax errors on this. What would be the problem if this were in C#? What is it missing?
Semicolon.
Semicolons, yeah. Semicolons in JavaScript are optional. They're basically ignored if included. You can put them in, you can leave them off, it's up to you. For stylistic reasons, I would ask you to please just be consistent.
Do they like change anything? Like if you put them or if you don't?
They allow you to put more than one line on one line. So, for example, if I were to do something like that, that is legal JavaScript, right? But if I were to remove this middle semicolon, that's no longer legal, right? So what it allows you to do is put multiple statements on one line, but I don't recommend putting multiple statements on one line anyways, right? Like the compactness is not usually worth the hit you take in readability, right? So, that's technically what the purpose of the operator is, under normal usage you can leave them out and it doesn't matter. Again, for stylistic reasons, I would just ask you to be consistent. So, we are still using curly braces. We are, once again, in JavaScript as in C#, including new lines and indentations for code readability. It is not for us. It's not for the interpreter, it's for us. So please do that. One thing that's interesting about JavaScript is it's not going to auto indent you to look like that with the curly brace on the next line, the opening curly brace on the next line. I'm not sure why C# thinks, or I'm not sure why Visual Studio thinks that's intelligent. It just wastes lines of code. I don't know. Everybody codes like this, okay? Pretty much everybody. Although I guess there is some active debate on the topic. But anyway, aside from the differences in the equality operator, which we already talked about, if statements function exactly the way that they did in C#. We get a yes, because y is less than 50. Make sense? So far, so good. Is there, okay, I'm we're gonna do like the different loop types, and then I'll ask you if there's anything you wanna see mapped over, okay? So, what's our first loop type, remembering from last semester?
While.
The while loop, that's right. We won't bother with do while. I'm not sure that JavaScript even supports it. So, while. Let q equal 0, while q is less than 10. Console.log q plus plus. That's what a while loop looks like in JavaScript. As you can see, this is precisely how it looks in C#. There we go. Let's do the for loop. So recall in Java, or in C#, for loops look like this. Right? This is hopefully familiar for people. Right here, right now, for let I equal 0, I is less than 10, I plus plus. There you go. So, once again, JavaScript variables are not declared with a type. In our C# declaration, we need to know that this is an integer. In our JavaScript declaration, we use the let keyword instead. Make sense?
Does the let keyword refers to the q equals 0? Basically.
Sorry. The let keyword refers to the...
To the declaration you made up there, like let q equals 0.
Oh, well, no. So it doesn't refer to other uses of let. What it does is it binds it to a context. So I think that I should be able to interestingly demonstrate this now. So, there we go. So, let me. I now have enough sort of meat on the bones to give you a demonstration of let versus var. All right. So, this 0 to 9 here is originating from this loop. Let I equal to 0. I is less than 10, I plus plus, console log I, right? Printing them all out in sequence. I then try to print I after the loop. Error, I is not defined. Right? So, when I define this guy here, he is bound to the context of this loop, which means he doesn't exist outside of it, which means he doesn't exist here. Does that make sense? So the let doesn't have anything to do with this guy. It's just here. This is actually something that's technically not possible to do with a while loop, actually, is to bind the variable like that and still have a function. Now see what happens when I change that to var. It still exists outside of the loop. It's not been bound to the local context. It's been bound to the global context. So just when the loop, it doesn't last as long as the loop anymore, it lasts forever. Does that make sense? Does that, any questions? Okay. Good. Did we talk about for each loops last semester?
Yes.
I don't really want to talk about for each loops yet, because it's a little weird. For each loops in JavaScript are not first-class language constructs. Basically, there's no statement for it. What you do is you call a specific function on a data structure, and that's a for each loop. So we're just going to not do for each loops for now. If they come up, we'll talk about them, but they're kind of weird. I'll show you an example. I myself find it difficult to reliably reproduce one. Yeah, because it involves a lambda. That's what a for each loops. That's what a for each looks like in JavaScript. You call for each as a function or as a method on a data structure. So, are there any language constructs that you'd like me to show you the JavaScript equivalents of? Or is everybody cool? Yeah? That's an excellent one, actually. That's actually the next one we were going to do. You have given me, what you thought you gave me was a question, but what you actually gave me was a segue. So, you know how C#, you need to know the context, declare it in the right place, and know what the return type is. Here, you just type function. Ta-da! Type function, give it a name, foo, round braces for the argument list. Those again don't need types. X, Y, Z. Console.log X plus Y plus Z. Bing, bang, boom. There's a function for you. If you want your function to return something, same as in C#, you also need a return statement. But, and aside from the fact that this is not a method of a class, this is a function, it otherwise behaves pretty much as you would expect it to. A cool thing about JavaScript functions is that they can be called from the console if I just call foo, I get man. Now, this is not a delicious, delicious thing to eat with curry, because that would have two A's. NaN stands for not a number. It's a special error code value that JavaScript produces when it attempts to perform numeric operations on things which are not numbers. Now this is where we kind of start getting into some additional interesting differences between JavaScript and C#. So JavaScript has a very common null type called undefined. It's a null literal. Undefined. So this is what's happened, right? I declared this function foo with how many arguments? 3. What were they? X, Y, and Z. That's right. So basically, foo has space for X, Y, and Z, which have gone undefined. So when I use the function like this, I have supplied 0 arguments. Therefore, the undefined value is applied to each one of these arguments which I have supplied, which I have failed to supply. Therefore, if we remember what the content of that function is, return x plus y plus z, what we are essentially trying to calculate is undefined plus undefined plus undefined.
3 of them.
Yes. 1, 2, 3, x, y, z, right? Because the actual statement is return x plus y plus z, right? So we substitute into that, that's what we get. Now the question is, what is undefined plus undefined? And you can probably take a wild stab at it. Nope. It is not a number. I believe anything plus undefined is not a number. So if we then add undefined to not a number, we get not a number as the result again. That gets printed. That is how it worked. Incidentally, on the subject of return types, if you write a function, you do not have to supply a return type. You also don't have to have a return statement. If you leave out the return statement, the thing which is returned from the function is, again, undefined. That undefined over there. So this is basically how it's choosing to handle polymorphism, rather than do it in some kind of nice structured way. Anytime somewhere there might be something, but there isn't, it inserts undefined for you, whether you want it to or not, and whether it's going to screw up calculations or not. This is, again, why I absolutely advocate to the largest extent possible, programming in this language as if it were C#. Don't rely on this stuff. Make sense? Any questions? So, now I'd like to show you how to hook a button up to a JavaScript function, because it's actually quite simple. Let's make a button element. Let's say 1 plus 2 plus 3. And let's give it the onClick. Call the function foo with values 1, 2, and 3. Refreshing the page, you can see we now have the 1 plus 2 plus 3 button here. And if we click it, we get 6. As many times as we click it. Make sense?
So this is the code for the function. You did the other
I'm sorry, can you
page.
speak up a little?
Is this the code for the function you did like the other page?
So here, let me split things. There we go. So this is the code for the function. This attribute here, I have said that when this button is clicked, call this function with these arguments. It actually has nothing to do with the label text here, but that needs to match for it to make sense, right? But the label text doesn't actually do anything. I could name this anything I want, right? And it would still, it wouldn't change how the code is executing. Any questions? Okay, so I think we can slip back into the slides now.
Still have that spot.
So we have a few slides on some of the more specific, a few more additional rules about JavaScript semantics. So again, we went over the difference between let and var. Let declares it within the local scope. But this is an interesting description of what happens if you don't use let or var. So basically, what happens is that you start searching for the variable in the most local context, and then you go down the scope chain towards the most global context, And if you hit the global, most global context, and you don't have an X here, an X declared, then it declares one in the global context. So I'll give you an example. So JavaScript uses block level scoping, which means basically scoping is easy to remember because it's curly braces, right? That's where your variables are scoped. So let's imagine we had global scope let x equal, or I guess that would be var 5, let y equal 10. Right. So here at this console.log, if I asked for the value of y, what would it give me? 25 is correct. Because it looks at the local scope first, right? What if this were x? What would x be here? 15 perhaps? Well, the first thing it does is it checks the most local scope, doesn't find it, so it goes to the next scope, finds it, 15 is correct. Very good.
That's the same.
What did I say?
Like the fourth one, that X is 15, that's it. Is that also?
Yeah, that's a cursive Z. In case you need a reference for my handwriting.
I think Phoebe knows cursive. I think Phoebe knows cursive.
You guys never taught, you never did cursive at all?
I think I was the last that learned cursive.
You know that if you learn cursive, you can write like literally 2 or 3 times as fast. Good grief. How are you supposed to read like letters that your great grandmother sent to her heart throb during the war?
Slowly.
What is it called? Cursive?
Cursive, yes. So the general principle behind cursive is that you can write a word without lifting your pen from the page. So, you know, instead of the quick brown fox jumped over the lazy dog. By the way, if you've never seen this sentence before, it's famous because it uses every character in the English alphabet. Instead, you have the quick fox jumped over the lazy. It's hard on a whiteboard. Dog. Some people have better cursive than others. Personally, I'm a doctor, so I get, doctors are supposed to have miserable handwriting. Yeah. But you can see how much faster I wrote that, right?
The name is interesting.
Yeah, I don't know where it comes from, actually. In school, for me, they didn't call it cursive. They called it handwriting, which, this was printing, this was handwriting. What? Yeah, now printing things is, but when I was going to school, the only time you'd ever use this is if you were like drafting. You're not supposed to use cursive on drafting, but like everywhere else you were expected to handwrite everything.
What is drafting?
It's like drawing up blueprints. Drafting drawings. This kind of stuff. Excellent example, actually. Man, that's a good example.
I'm curious.
Oh, I'm sorry. Here. Here, I forgot that. It's like, if you wanted to draw up a plan of like a building or more often a mechanical part, you would produce a drafted drawing. Now, these days, of course, it's all done with software. But, there was a day and a time when these drawings were all produced by hand, of course. Like, have you ever seen like those really big tables that are like at like this kind of an angle? Those are drafting tables, because these sheets were often quite large, because like precise measurements would be taken from these drawings to calibrate the machines to manufacture the parts. In fact, that's still something that's done, right? Although you can also take more precise measurements from the software itself, so that's done more. But yeah, I was just telling them that like when I was in school, you were expected to handwrite everything unless you were drafting, in which case that's where you printed stuff. So.
I was wondering how we went from cursive to here.
Yeah. Did they call it cursive for you? Yeah. For me, they called it handwriting.
Like I said, my grade was like the last grade before they took it out of the curriculum.
So remember my
So
brother.
literally everyone younger than me does not know how to read cursive unless they were taught it by somebody not in school.
That's the cursive. This was taught like in the English class? The cursive?
It was like grade 3, like
Yeah.
not even I don't think it's English at that point. It was just like class.
School.
Yeah, this was taught early enough that you weren't really like, it wasn't math class. It was like, here's your math lesson, Yeah, no, Yeah, like grade 3, grade 4 kind of territory. Yeah, as soon as you were able to print reliably, they move you up to handwriting because it's faster and you can get your work done faster that way. Like, I don't understand why they cut it out, because like you yourself can do schoolwork much faster if you are cursive writing. I don't understand
It's
why.
very strange. I feel like it's more an instinct than it's something teachable. Like, I never learned it. I just, when I write fast, I have to write
Yeah, you
fast.
just kind of,
Yeah.
yeah. But there's certain like elements of form that like actually like a lot of the capital letters look a little weird.
I mean, it could be the concept of eventually we got to a point where they could see that more than likely notes and writing was going to be done on computers going forward. That's an even faster way than writing it all out is to type it out.
Sure. Yeah. Yeah. Definitely. People are, and people don't need to know how to do math either. You know.
I mean, they're talking about introducing coding in elementary school.
Okay. You want my opinion on that one? You can't like. You're not really. You shouldn't like. It's too young for kids. Like, I think about grade 5 they want to do coding, right? Something like that. But it's too young. Like, you have to know algebra first. Like, if you don't know algebra, then you don't know how to work with numbers symbolically, which is what you're doing in coding. It's not going to work. Like, you'll have the math geniuses, of course, who'll pick it up because they'll pick anything you throw at them. But like for everything, also like I kind of like I object to this idea that like there are so many jobs in software that like it's the new hope for the future employment of the new generations. Like, if you look at the amount of people actually employed in the software industry, like it's not a booming field. You know, like it's really not. Anyway, cursive capital letters are an interesting subject. A, B, C, D, E, F, G. G is an interesting one. H.
This is capitals, right?
These are capitals, yeah. I. Now I do my I's bad. I think I do mine backwards. I'm supposed to do them like that, but I do them backwards. I think something like that. Maybe you're
No,
supposed to
that's
do them.
right. I feel like it's just normally more of a little gap
Yeah.
between the first
J. Yeah. You know, a fight between me and my 3rd grade teacher, you know. K, L, M, N, O, P, Q, R. It looks like a 2. You right? S. S's. Yeah, it looks like a G, but it's not. The G has the tick. The G has the tick. T.
I always thought the S looked like that music symbol. Like,
Yeah.
yeah.
V. W. X. Y. Z. And that's. I think so.
So what are the lower cases for some of these and the cursive are great?
A, B, C, D,
Just
E,
the size?
F, G. Some are just bigger versions of other ones. But that's also true of letters. Think about X.
Yeah,
H, I and T, you have to lift your pen to do the dots and the crosses. J and J, nobody talks about J though. K, L,
Some people
Yeah.
don't even put the dots on the I and the J.
yeah? Yeah, I guess depending on how dedicated you are. O, P, Q, R, S, T, U, V. So U and V is an interesting case study, right? The difference between the cursive U and the cursive V is that at the U, the tick comes off the bottom, and the V comes off the top. W,
This is where the doctors get crazy.
and X, Y, Z. And I'll throw you in ampersand just for good measure.
we use ampersands.
Oh yeah. Ooh, in that case, I'll throw you another one. Nope, this one. With, that's right. Pittman shorthand. That's another topic for another day. I'll show you quickly though. I don't know I don't know Pittman shorthand, but my mother took a secretarial course in the 70s, and this is the sort of thing they taught.
This is like without. You know my last name is Pittman.
I do recall that now, actually.
Spelled different.
So your great-great-great-grandfather wrote this.
Yeah, and I really let them down. I don't even know what it is. I don't even know what cursive is. What is D, J, J, Wow.
I regret one
So this is the type of, so they taught Pittman shorthand to secretaries in the 70s who had to take dictation, right? So they could write down at a speed comparable to someone speaking, so that they could then transcribe what was spoken into a letter afterwards.
This language is the one that they used in World War II for the spies and all that.
Yeah.
Between the Germans and
Yeah. I mean, it's fascinating stuff, you know? I mean, you're talking to a guy who at one point was fluent in Fez glyphs, but Fez, the video game. But that's just an easy substitution cipher to English. So anyway, arrays. You can write arrays in JavaScript. They are very, very useful. Are they arrays? Are they lists? It's a dynamic language, so they're probably lists, not arrays. Even if they call themselves arrays, they will be probably lists. Arrays are objects. They can hold multiple data types and are zero indexed by default. So you remember that thing where if you declared an array in C#, it was an integer array, and you only put integers in it on pain of death. Here, you can put any old thing you want in there. Numbers, words, Boolean values, cookies, fish, everything. Philosophical statements. You can put anything you want inside of an array in JavaScript. JavaScript doesn't care. You access array elements using square braces the same way that you do everywhere else. Elements not yet defined will return the special value. Undefined, as you can see, JavaScript likes to do that a lot. So, oh yeah, JSON. JSON is going to be I'm gonna level with you for a moment, right? For like a lot of programming constructs that people have problems with, I can kind of like understand where people come from on why they're having trouble with it. But this one just like, it just eludes me. I don't know why it is people have difficulty with JSON, but it seems that people do, and I'm sympathetic to it. I wish I understood what the mental block was with JSON. It might be the fact that it's such an inherently nested type of data structure. So JavaScript objects are terrible, like aside from object notation. Basically, we have a quote-unquote object-oriented language with objects but no classes, right? So if you recall back to last year, the way that we did objects was we defined a class. We said, this is our definition of a cat. We will instantiate this definition to produce a cat. That is how an object works in a typical object-oriented language. In JavaScript and other interpreted languages, Python is vulnerable to this as well as PHP. This is how it works. Imagine I'm trying to get to the cat object again, right? I don't start with my definition of a cat and then, instantiate it. I instantiate an empty object. It's like, well, I have a thing. And then you add to it all of the properties the cat has that you would have defined in the class. My thing has whiskers, my thing has claws, my thing goes meow, and eventually it becomes a cat, right? As opposed to saying, here is a category of things with claws and whiskers that say meow. I want one of those that's a cat, right? That is the C# way of doing it. The JavaScript way of doing it is saying, I have this amorphous blob of a thing, all right? I have an indeterminate, indistinguishable thing. By the way, it has claws. By the way, it has whiskers. By the way, it says meow. And I'll leave it for you to determine whether you think it's a cat or not, because of course typing doesn't matter, right? Because JavaScript is JavaScript and typing is dynamic, so it's not going to actually admit that a cat is a cat at any point. If you have a function in C# or Java that expects a cat and you give it a dog, it'll say, hey, I was expecting a cat and you gave me a dog. If you have a function in JavaScript, it has no ability to say, hey, I wanted a dog and you gave me a cat. All it does is say, oh, thank you very much for the object. I will do my best to process this no matter what kind of crap you gave me. That is JavaScript. So basically, JavaScript objects start off empty. The empty object in JavaScript, by the way, is two curly braces directly adjacent to each other like that. It's like an empty list with the two angle braces, but curly braces instead. That's the empty object. So empty object, you then add properties to it. Every time you add a variable, you are actually adding a key value pair. Pardon me. Objects can, of course, have sub-objects, and objects can contain arrays. And this is where the idea of the JavaScript object notation comes from. So JavaScript object notation is a way of taking JavaScript objects and writing them down as strings so that they can be transferred back and forth between different things. This has become a very common way of sending data between client and server. It's even become popular for what are called NoSQL databases. They're typically based on JSON data rather than based on traditional relational databases. So data appears in key value pairs. That's nothing new. That's the same way that variables work. A variable has a name and a value. So a JavaScript object is a collection of names linked to values. The value might be any of your basic data types, or another object, or a list, or an array, right? Otherwise, you represent this in basically the same way as you would be writing it into a programming language. You separate the pairs with commas. Curly braces are for objects, square braces are for arrays. And maybe, let me see what time it is. I think we should have another break. And when we return, I'll show you an example. Okay? There we go. All right. We have all of the C syntax control structures in JavaScript. We also already talked about this largely.
Is the switch case the same thing as C# in here?
Yeah. Yep. Pretty sure anyway. Yep, it's the same. That's good. That makes it better than Python. Python doesn't have them. Oh hey, look, I managed to hit the exact one that was in the slides without even looking. Defining functions, already talked about this. We can pass functions as arguments to other functions. We can and we will It turns out that one of the ways that we are going to set up events is defining the thing that happens in consequence of the event as a function, and then passing that function referentially into a thing that uses it to set up the event. Good. So, it's about, we should take a moment to discuss the difference between, or let me show you, there are two functions that you can use to set events. These are kind of your entry-level events. These are timer events. So there are two of them, set interval and set timeout. I'm going to write for you two of the most annoying programs that you have ever seen in your entire lives. So let's write a function, annoy, alert, what's something annoying? Breathing. Here we go. So, right now, that function is defined but never called, so it will never actually activate. If I set timeout, I have to provide, first, the function name that will be called once the timeout expires. So it's like, yeah, yes?
Is timeout like a function that is already defined inside of JavaScript?
Yes. It is a library function or a prelude function. Yes. So set timeout is already defined for us. What it does is it says, call this function after this many milliseconds. So annoy after 2000 milliseconds. There we go. Did I close the window? Good grief. There we go. Oh, there it is. Notice that that was a 2-second delay from the page being loaded. There we go. But it only occurs once. The super annoying one is set interval. Set interval sets up a repetition. Every second, it calls the annoy function, which means that I get this thing, oh, did I crash it? Anyway, what's going on? Interesting. Anyway, the function gets called once every second, and you can see that the boxes actually like accumulate. So like I have to click through the whole stack of them to get back to the web page. So it's become functionally impossible now to access the web page. Right? Now, I want to show you all a fun example of how you can use set interval to cheat at a video game. So, cookie clicker. Yes. So Cookie Clicker is a game. Is this the one? Which, is it cookieclicker.com? Is this the one?
I think so, yeah.
All right. Web version, please. Thank you. You won't get Steam achievements for this one. So, this is Cookie Clicker. It is a game where you click the cookie and you get cookies. Very good. But this game operates on JavaScript. So, if you take a look here, they store the game data inside of an object called game. Right? And you can take a look at a lot of interesting game data, possibly also including the number of cookies somewhere. But there are some interesting things in here, such as game dot click cookie. Now, click cookie, if you just run it, you can see you get a cookie. So, we've not yet really achieved anything, as we can now call a function from the console to get the same effect as clicking here. However, we know some programming, don't we? Set interval game dot click cookie. There we go. Oh, let's have that operate once every millisecond, shall we? Boom. I think. Did I do it right? Oh, I know what I'm doing. So this is a very easy thing to get wrong in JavaScript. And one of the nice things about JavaScript is that it doesn't tell you when you get the stuff wrong. Like, it'll just do it and not give you an error. By providing the round braces, I'm actually calling the function instead of providing it referentially. So if you just take away the round braces, there you have it. I'm now clicking the cookie at incredible rates. And if you want to, you can set a few more of those. It probably caps out at some point, right? But you can see how many cookies you're getting just from your base. I think there's even there's an achievement for cheating in this manner.
It's called uncanny cookie.
Yes. Basically, the game knows you're cheating, but they don't care. So there you have it. So setting intervals. You call JavaScript functions on a timer rather than having to do it yourself. And you can use that to cheat at video games. So, impress your friends, fool your enemies. Good. Get out of my face. All right. So, but that's the idea behind events, right? We set up some kind of thing, some kind of trigger, and that trigger causes a function to be called, right? So, an example of this, which we've already seen, is the thank you, the on-click event, which we previously hooked up to a button. Now, we can hook on-click events up to many things that are not buttons. But just because it's a button doesn't mean the only thing we can do is the only thing that you can click. Obviously it works. Other common events include onChange. OnChange is something you use when somebody's entering information into a form. Did they have an onChange event in Windows Forms? I forget.
I don't think we used it.
No. So a very good example of an onChange event. On certain websites, when you're entering into the entering your phone number into the web form, it like fills in the dashes for you and like formats it as you're going. That's JavaScript, right? What it's doing is it's running that JavaScript in the back end to fill those pieces in as you're going through, right? But that's a trigger. That's not always listening. It's waiting for something to change inside of that box. That's what the onChange event does, right? OnClick should be obvious. On mouse over is your cursor enters the region. On mouse out, your cursor exits the region. On key down, a key on the keyboard is pressed. On load is a particularly interesting one. When for example, an image file is retrieved from the server and loaded into the browser, on load. Yes, all kinds of different events. Okay. I know that we're getting kind of close to the end of class, but do you mind if we have a short break while I go and get myself refill my tea?
Absolutely.
All right. I'll be back. And then we will talk about the document object model.
I heard it from here. You couldn't hear it?
No, you're almost. I think it's something
No,
like
James.
Okay. Let's talk about the JavaScript document object model now. So it's all well and good to do all of this abstract calculation in JavaScript. It's good to know that you can do all of those sorts of things, but fundamentally everything in client side ultimately comes down to the end user. If we can't show the user something, what is the point? So we must understand the website from the perspective of the document object model. The HTML gets modeled as a hierarchy in much the same way that a JSON is. All of that conceptual work we just did to understand how to run through a JSON object also applies to running through the HTML itself. Now this is okay. because with HTML, we kind of intuitively already understand it as a hierarchical thing. We understand that some things go inside of other things, right? Now, there is some particular terminology. When a thing is inside of another thing, we call that thing a child of the parent, right? This is the same terminology we use on tree structures, such as right here. This is a child of that, right? Child, parent, also sub-thing, super-thing. So, in HTML, this paragraph is a sub-element of body, which is the super-element. Body is itself a child of, anybody? HTML is correct. Very good. Yes, very good. So it's normally given by indentations, although that one isn't. That one's usually omitted just for, you know, it's a lot of indentations otherwise, right? So yeah, the way that the HTML file itself organizes is hierarchically. However, most of the time, when we access elements of the document, we do not start at the top and find our way down through the thing. We use search functions. We also don't do that when we're trying to find things on the internet in general. We use search engines. So, there is, the slides claim two, but I'm going to say there's really one thing that you should do to find that. Query selector or query selector all, depending on how many you want to get. So, if we take our page, in order to work with any of the elements on the page, we need to create a reference to that element and save it as a variable. At least in JavaScript vanilla version, that's what you do. So, basically, I want you to think about things this way. I'm going to erase my lovely cursive writing now. Is that okay, guys? Okay. Yeah, everybody took notes? Okay, good. So, I want you to think about the distinction. I want you to think about different memory regions. All right. So, we have document memory. Right? Document memory contains the page itself. It contains the document object model. So we have HTML, head, body, H1, right? Very simple HTML file, but that's document memory. We also have JavaScript memory. I hope that was referring to something on your computer and not my lesson. So JavaScript memory is where all of your variables and all of the things we've been doing in this class so far, that's where all of that is contained, right? The browser holds these two things separated, right? So if you want to make a variable, you know, x is 5, y is 10, this stuff, that type of stuff, that's held in JavaScript's interpreter memory, right? That's different from document memory. JavaScript memory, well, JavaScript operates on things in JavaScript memory. In order to operate on this, we need to pull a reference in here, right? Now, references are kind of a tricky subject, right? I'm talking about pointers, with trying not to talk about pointers. So, I want you to imagine this. I create a reference variable, let's call it foo. I create a variable, I call it foo. I want that linked up to something in the document memory, right? By linking up, I mean, instead of containing a number, such as 5 or 10, this box contains a one-armed octopus, all right? So we've got a one-armed octopus, all right, named Foo. When I use a function like getElementById, the return value is a reference to the element in document memory. It's not the element itself, it's a reference to it. Pardon me. If I assign that to my variable foo, then my little octopus stretches his arms all the way into document memory and suction cups himself to the element that was returned from that search operation. All right? And then, because he's a clever octopus, and octopi are known for their ability to mimic things, some of them anyway, he says, I'm now an H1. There we go. All right? I am now H1. I am not an octopus. I am H1. Right? Any modifications that you make to this variable will be transmitted to the document memory, even though the document memory hasn't gone anywhere, right? This variable is pretending to be something inside of here. This is the concept of a reference. Is this, any questions about this? Does this make sense? Yeah. So our little octopus friend, who is now pretending to be a heading, we may now make modifications to him and modify properties of the heading. For example, if I wanted to set the contents of the heading, I could say something like foo dot inner HTML is equal to I am not an octopus. And that would work. We would have to establish it first by saying var foo is equal to document dot query select h1. This line establishes our octopus. This line sets a property through the octopus. Sound good? Shall we see? Question?
So if you did it as H1 without an ID, would it set all H1s in the document to I am not an octopus?
Excellent question. That's the difference between query selector and query select all. Query select and query select all. Query select only selects the first element matching your search query, and the search query is actually a CSS selector. So the same selectors that we were using in CSS, we can now use in JavaScript to pull elements out of the page here as well. If I said query select all, then I would get all H1. Now, if I had done that, I get a list back, right? And you cannot, like, if foo were a list, it would not have an inner HTML property. I would have to walk through that list and set the inner HTML of each element individually, rather than do that. But yes, in general. Did I do the Rickroll example with you guys? Yeah, the Rickroll example is this, we've now come to it in the course, right? In that case, I collected up all of the links on the Wikipedia page and I set their href value to the Rickroll, right? So yeah. Get element by ID. If you have any experience with JavaScript, you may have seen that before. Does anybody here have any experience with JavaScript? Okay. None of you will have heard of this before, but this is like the old crusty way that only graybeards use now. Basically, it was popular for some time before query selector came along, but it requires that the thing that you are targeting have an ID, right? Query selector does not require that the thing that you're targeting have an ID. Like, it'll have an ID most of the time, or yeah, like, or perhaps much of the time. Like, if you have several buttons on a page, IDs are the obvious way to distinguish between button 1, button 2, and button 3, right? So you will be using IDs quite a lot of the time, but query selector does everything that get element by ID did and more. So that's why people are moving over here now. But yeah, any questions about that? Good. Let's see, I think we got one slide left. Let's see if we can do this slide. So we can alter properties of elements of the document. We can also insert new elements into the document. We can also remove elements from the document. We can do something like look up a particular element and destroy all its children. This might seem unnaturally cruel, but you know, that's programming for you. You can alter the contents of HTML elements so this line of code gets the element with ID my ID and sets the inner HTML. Inner HTML is everything inside of the tags, even if that includes other tags, to paragraph, the new contents of the tag ID, my ID, and paragraph. We can also alter HTML attributes like the value of a form input text box. Here, you can also do things like modify style properties. Element dot style dot color equals red, for example. Everything that you can do in any other way can also be done in JavaScript. Technically, you can write the entire page in JavaScript and then have it run the JavaScript and generate the entire page for you. Although I wouldn't recommend it because right tool for the right job. But yes. Any questions about that? No? Okie dokie. I will leave you with a joke. I don't think I showed you this one. There you go. Programming versus demon summoning. You must know languages unspoken by mankind. Check, check. Requires that you be exact or suffer dire consequences. Check, check. Involves a bunch of cursing, swearing of oaths, and pleading with higher powers. Check, check. Not understanding the true power you wield or the consequences of your actions. Check. Programming, demon summoning. Sometimes you have to execute a child. Programming, demon summoning. Candles, only demon summoning. You don't need candles to program. Yeah. So there you go. All right, that's about as much damage as we can do for today. We'll do some more programming examples tomorrow. Let me just take a look and see at. Let me just give me 1 moment to take a look and see what we got going next week. jQuery and Bootstrap. Oh boy. All right. Yeah.
This is now week 4.
What? This is week. What? Oh yeah. Well, yeah, but like we lost the Monday.
We did.
Yeah. So, like our first week, we only had an hour. Don't worry. I think all the due dates have been worked out on the basis of that already. So, yes. This weekend? Yeah. Is everybody feeling good about that now? Hopefully. We'll do some programming examples. Tomorrow will be just programming examples, okay? Perhaps I'll even focus those specifically on what the assignment is requesting for of you.
The assignment requested me JavaScript.
Oh, really?
Yeah.
Oh, good.
I think it's all just like the stuff we did in the
Yeah,
first 2 weeks.
just HTML and CSS.
All right, then. Sounds good. Never mind. I'll do whatever I want then. Talk about cursive writing again. Close? Stupid. Stupid. All right. All right. Thank you very much for your time and attention, folks.
Thank you for showing up while you're sick.
Yeah, I'm going to go home and lie